Okay, so I'm going to try doing U substitution, okay? So this is an outside inside. I'm sorry, I didn't mean U substitution. I'm going to try and do outside inside. So y prime, what's the outside? The tangent. So it's secant squared. That's the inside or the outside. Oh my word. This first period calculus is rough. Okay, that's the outside. Now the inside, so times the derivative of the square root of 2x minus 3. Okay, there we have outside, inside. Everybody with me? Okay, so now let's take the derivative of that. So this is actually 2x minus 3 to the 1/2. This is another chain rule.
Why would we change the 1/2 on the first?
We just didn't have to, and I thought throwing in that 1/2 just makes it look complicated.
Keep it in 2 different forms.
No, I'm going to put it back in all the same form at the end.
But like, if I were to like keep 1 as like to the 1/2 and then 1 as to just the square root, would that be acceptable as an answer?
Acceptable, but not preferable.
What is acceptable?
Okay, so now we're working on the inside part. Okay, I'm working on the inside part. So this is another chain rule. So the outside is going to be what on this chain rule? 1/2 2x minus 3, and this is going to change to negative 1/2. And then the inside is what? 2. Okay. Okay. So we have y prime equals secant squared times the square root of 2x minus 3. Now my 1/2 and my 2 cancel. This is times 2x minus 3 to the negative 1/2. Did you?
Yeah, that's what I have too.
Okay. My mistake when I went around.
I just have it. I have the first radical as a 1/2.
Okay.
Wait, why'd you press? Oh.
1/2 times 2 is 1. Okay, so I'm going to go ahead and I'm going to rewrite this as secant squared times the square root of 2x minus 3 over the square root of 2x minus 3. Okay, you can have it in different forms. That's okay, as long as they are equivalent. And sometimes, like if I'm taking an AP exam and I rewrite it like this, I'll check that on my calculator to make sure that they are equivalent. So I'll just quickly put this in y1 exactly the way it is, and then I'll put this in y2 exactly the way it is and see if they end up being the same line. Then I know my equivalent statement is true. Okay, so I just take that. Yeah, if I have time. It's hard. You should have plenty of time with the multiple choice. The free response questions, you're probably going to run out of time. But we will work on those strategies for the free response questions later. Okay. How'd you do with your time? Do you feel like that's true? Multiple choice, you had plenty of time?
I came nowhere close to finishing.
Yeah. Yeah. Right.
I think I didn't leave an entire one blank, but there were sections that how long is it? It's 6 FRQs, and it's similar to the calculator.
No, we answered
I feel like, how much time do you have for the FRQs? Do you remember?
I could be wrong though. Not enough time. It will be different.
I feel like you had a half hour for each FRQ, and they take longer than a half hour. Let me see.
Should we get a sample one?
Oh, we will. Don't worry about that.
She said 2 out of 5. 2 out of 6 in the bottom.
So you have, so the FRQs, which stand for free response questions, the first section, which requires a calculator, 2 problems, 30 minutes. So that's 15 minutes a problem. Not nearly enough.
Do the phones have parts, or is it just like
Yes,
So this particular practice test that I'm looking at, the first question has 5 parts. You have 15 minutes to do it. The second question has 4 parts, and you have 3 minutes to do it.
So what they're saying is you either have to know the question or you don't.
Right.
3 minutes.
So, yeah.
It takes me
Or if you know the question, no. Like, that's like
So-
figuring that out.
So basically, they've allocated about 15 minutes per free response questions, and they're always 3 to 5 parts. So yeah.
you can also go back to the calculator ones, but you don't have access to your calculator. So if there's like a problem that you know, if you like give it some time, do the calculator parts and then you can do whatever else.
Right. So we will go over test taking strategies when we get closer, but basically each free response question is worth 9 points. Most of the time, you can do the first 2 parts of all the free response questions. It's the third and fourth part that get more complicated. If you did the first 2 parts of every single free response question, you're going to score amazing. Okay. So one of the strategies that we'll talk about is not to spend forever trying to answer all 4 parts of the problem, because you're going to run out of time. You're not going to get it right because you spent so much time on it. Chances are you didn't actually know how to do it. And then you're not getting the first couple parts of the other question. Just like on your SAT, right? All the questions are worth the same. Why are you going to spend 15 minutes on one question when you could have just done 10 more problems, right? So it's the same type of strategy, and we'll work on that when we get closer.
Miss Murray,
Yes.
do you have more example problems like these?
Yes, we're gonna do some more. So that's the end of the notes, right? So let's take out your homework 3.1. Your homework 3.1. Do you guys want to take a short little break? Stand and stretch or whatever? Yeah. Okay. So I'm going to go back to the homework 3.1, and I feel like numbers 1 through 8, you guys were pretty much okay. It was when I got to 9 and 10 that you had trouble. Is that pretty accurate? Okay, let's work through these again and see if it helps. Okay. So let's look at number 9, all right? One of the reasons that, just like in algebra 1, we make you write everything out, right? We make you do plus 3 on both sides of the equation, right? Is so that when you get to the more complicated versions, you can follow what you're doing, right? So we're going to do the same type of thing. So first off, we're going to rewrite this. Y equals 1/2 x squared, parentheses 4 minus x squared, okay? So y prime, which by the way is the derivative of y with respect to x. I think I said 1/2 and wrote 2. So remember, y prime, that's dy dx, right? We're taking the derivative of y with respect to x. So this is a product rule. Okay, here's the first, and then here's the second. So it's the first times the derivative of the second plus the second times the derivative of the first. Did you guys figure it out? Can't even figure it out with the answers, can you? Okay. With me so far with the product rule? Okay. So let's go ahead and let's work on, I'm going to kind of bring this off to the side and I'm going to work off there. I do that a lot with these more complicated ones because when you're stringing them all together, it gets so confusing looking. So we're going to look at the derivative of 4 minus x squared to the 1/2. Okay, just going to work off to the side. So how do you want to approach this? Outside, inside for this one? This is a more easier one for outside, inside. So outside, so we're going to do 1/2 times 4 minus x squared. So we didn't touch what's inside. This will be to the negative 1/2. That's the outside. Now we have to do the derivative of the inside, so it's negative 2x. Okay, so I'm going to multiply these numbers together. So get negative 2x and 1/2 gives me negative x times 4 minus x squared to the negative 1/2. How are we doing? Okay, so that goes with that. So we're going to rewrite that over here. So we have 1/2 x squared times negative x times 4 minus x squared to the negative 1/2. To me, doing it like this, taking that little chunk and just going off to the side and working, that makes it so much easier to me than to try to just do it in that big string. Because if you were just kind of writing it out here, you'd have all this stuff and it would get, you lose stuff. You literally lose things, okay? Okay, now the next part. So we got plus 4 minus x squared to the 1/2. Now this is an easy one to differentiate because this is the old stuff, right? So 1/2, we're going to take the 2 in front. 2 times 1/2 is 1. So we're just left with x. Okay, so now we just have to clean things up a little bit. Y prime equals, so I've got a negative here, so it's negative 1/2 x to the third. I'm distributing. Okay, I'm distributing this 1/2 x squared. Okay, and then this is times 4 minus x squared to the negative 1/2 plus x times 4 minus x squared to the 1/2, and we're done. Okay? Questions on that? Okay. All right, number 10. Do you want to do low-D-high or product rule? Okay, so let's rewrite this. This equals x times x squared plus 1 to the negative 1/2. Okay. Okay, so we have f prime of x equals the first times the derivative of x squared plus 1 to the negative 1/2. First times the derivative of the second plus the second times the derivative of the first, right? These are more complicated now, so I'm writing things out so I don't lose stuff. Okay, so I'm going to take this derivative. I'm going to work off to the side. So the derivative of x squared plus 1 to the negative 1/2. Okay. This is a chain rule, so we'll do outside, inside. So outside, negative 1/2 x squared plus 1 to the negative 3/2. So when we say outside, that means we're not touching anything that's inside the parenthesis. To the and times, now we're doing the inside, 2x. So let's see, negative 1/2 times 2x, that's negative x again, times x squared plus 1 to the negative 3/2. So f prime of x equals x times, and we're going to bring that over, negative x times x squared plus 1 to the negative 3/2 plus, what's the derivative of x? 1. So it's just plus x squared plus 1 to the negative 1/2. So again, we just have to clean it up. F prime of x equals negative x squared, right? I just distributed, times x squared plus 1 to the negative 3/2 plus x squared plus 1 to the negative 1/2. And we're done. Okay. Are we ready for 11?
Negative x in the brackets.
This negative x right here, where did I get that? Up here, right? I did negative 1/2 times 2x, which gives me negative x. Okay. I'm going to use u substitution on this one. Okay. So I'm going to rewrite this as we're going to have to do that for the u part. So I'm going to do s of t equals u squared. Okay. Where my u is t minus 3 over t squared plus 2. Okay. Okay, so s prime of t, right? I'm taking the derivative of this. That's going to be 2u du. So over here, I've got to figure out what du is. So now we're going to do low d high over high d low. So we've got low d high. What's the derivative of the top? 1. Minus high d low. What's the derivative of the low? 2t. Over t squared plus 2 squared. Okay, so that gives me t squared plus 2 minus 2t squared minus 6t. So we get, let's see, negative t squared minus 6t plus 2 over t squared plus 2 squared. There's my du. Okay. I chose to do u substitution just because of the fact that I've got a chain rule that requires a quotient rule in there. Okay. Okay, so now I'm going to go back, substitute things in. S prime of t equals 2u. What does u equal? t minus 3 over t squared plus 2. That's u. Times du, which is negative t negative t squared minus 6t plus 2 over t squared plus 2 squared. Okay, just take a minute to make sure we didn't make any mistakes there. Okay, so on this one, we can simplify this a little further. I'm going to go ahead and multiply my denominators. So I have 2t minus 3 times negative t squared minus 6t plus 2 over t squared plus 2 to the third.
How did you get minus? I got plus 6.
How did you get minus t squared? I said minus 2t squared. 2t squared.
Okay, so when I distributed the 2t squared minus 6t. Okay, but then when I distribute the negative, it should be a positive. You're correct. That's a mistake. That should be a positive 6t.
And there should be a 2 in front of the t.
No, there shouldn't be.
Yeah.
It's negative t.
I've got t squared minus 2t squared, gives me negative 1t squared. Okay. Now you could factor a negative out if you want to and make the 2 negative, but it's okay. We can leave it like this. Okay. So looking at that one, the reason that I chose to use substitution is because when I looked at it, I was like, okay, I'm going to have to do outside, inside, or chain rule. And this is just something squared. I was like, well, that's easy to do. Like if I had a u squared, that's easy. So that's why I chose to use u substitution when I thought through this process. But you could easily just do the outside, inside if that's what you like. Okay?
Outside, inside.
Okay.
Do we have to simplify it any more, like distributing the 2?
No.
Okay.
No. Okay. We good on that?
I mean, I feel like the outside inside is the same as the distribution.
It is.
How to do it with the U's.
Yeah. It's the same thing.
So I know whenever we do outside inside for E, I automatically think E to the U
Right.
times derivative of U. So like, it's kind of already like programmed.
It's definitely the same thing. The u substitution is a way of organizing your outside, inside.
It's more of just like writing it out more.
Yeah. Yeah. But this would have gotten difficult to follow using the outside, inside. Okay.
Really?
Yeah.
I did the outside inside is easier.
Okay. See, that's just the way your brain works. That's
Then
good.
I make a simple mistake when we're doing those other ones, and I don't know why.
Just got to take your time. Take your time. Okay. So,
Something more than just
Wait, why are those answers here?
I don't know. That's what I was trying to think. Did we actually do those?
Oh, you did it before.
Oh, we did it for the test. Yes, we did that, but also not like I know.
So it would benefit us to do them again.
Yeah.
I was very confused.
I think Manny's going to cry.
I'm
There is no crying in calculus.
I'm for once a week. So. Oh, it's not your brain.
Okay. So what do you think on this one? What method would you like to use?
I would do outside.
Outside, inside? Okay. So the trig functions can be confusing. Okay. If I were to identify the biggest weakness that my calculus class has this year, it would be in trigonometry, right? So we recognize that, and that's okay. We continue to work on it, right? We're just weak in our trig. So we continue to work on it. Because of that, I would probably use the U substitution on this because you guys are weak on trig. And the more complicated looking the trig function looks, the less likely you're going to get it correct. So let's do the U substitution. So what would you call U? E to the 2x. Yes, let's call U e to the 2x. Okay. So what's our du?
E to the 2x.
Good. It's an outside inside, right? So it's going to be e to the 2x.
So it's 2e.
Good. Outside is the derivative of e to the 2x is just e to the 2x. The inside is the derivative of 2x. So this becomes 2e to the 2x. Okay. So I've got my u and I've got my du. Okay, so now y equals sine u. It's actually pretty easy when we do it this way. What's the derivative of sine u? Cosine. So y prime equals cosine u du. Right? So y prime equals cosine u, which is e to the 2x, times du, which is 2e to the 2x. So we're just going to move that in front. Didn't that feel easy?
It would be nice to
Yeah. Yeah. Okay. Yeah, that's okay. Yep. Okay, try to do number 13 by yourself. Use the U substitution if you can. Mm-hmm. Do you not have this worksheet? Oh, okay. Okay, just because we're going to run out of time, I'm going to jump in. Okay, what did you call U? So what's du? There you go. So y equals tangent u. So y prime, what's the derivative of tangent? Secant squared u du. So y prime equals secant squared natural log of x times 1 over x. So the U substitution works really, really well with the trig functions. Okay. So for homework, I would like you to do 14 to 17. Okay. Homework is numbers 14 to 17. How many of you are going to the game? All right, you got to be really loud. Be louder than their fans.
No, the Ram Nation's coming out strong.
Be loud. Be loud and obnoxious.